So in this video, we are going to review a system of linear equations. So there are three common ways to solve a system. There's graphing, substitution, and elimination. We're not going to do much with solving by graphing, but we're going to talk about what we're actually looking for. So when we're solving a system by graphing, what you're looking for is a point of intersection. That is where the two lines cross. And so when we're graphing two lines, you have three options for solutions. Our first option is one solution, and that is when you're going to clearly see that the two lines are intersecting at a specific point. We have infinite solutions. That's when it's going to look like you only graphed one line because the lines are the same. You have two of the same lines. And then no solution, you have two parallel lines. And so those lines never intersect. So I'm going to make a note that these are parallel. Okay. Now, that's all we're going to talk about graphing wise, because we're going to go straight into solving by substitution. So we do have some steps for solving by substitution, and as we go through our first example, I'll make sure that I clearly label these steps. So first off, step number one is to solve an equation for one variable. So what we're going to do is we're going to look at our example, and we're going to see, do we have a variable that does not have a coefficient in front? And the answer is yes. This is the only variable that has no coefficient in front. This one has a 4, this one has a -3, this one has a 6. The other two numbers, those are constants, so we're not worried about this. This x variable is the only one that does not have a number in front other than 1. We want to get that by itself. To get it by itself, we are going to subtract 6y from both sides. When we do that, that gives us x equals 4 minus 6y. That right there is step number one. Step number one says to solve the equation for a variable. Boom, we did it. Now what we're going to do is we're going to do step number two. Substitute into the other equation and solve. So we just solved for the variable x. So what we're going to do is we're going to take this and substitute it in for this x right here. We're going to replace this x with 4 minus 6x. So we have 4 times, and anytime we do substitution, we're going to put it in parentheses. We have 4 minus 6y minus 3y equal to -11. So here we go. We have 4 times 4, that is 16. We have 4 times a -6y, that is a -24y. We are going to drop down the -3 and the -11. From here, we can combine our like terms. So that would be our -24y and our -3y. So when we combine our like terms, that gives us a -27y. And now we can move the 16 to the opposite side by subtracting. If there's no sign in front of it, then you do the opposite by subtracting. If there's a sign in front, you do the opposite, which is usually adding. Okay? So what you do to one side, you have to do to the other side, because you do have to keep everything balanced. These are going to cancel out. We get -27y equal to a -27. So now, right here, we have -27 being multiplied by the y. So we're going to do the opposite, which is divide by -27. So when we do that, we get y is equal to 1. So all of this that we just did is step number 2. Step number 2 had 2 parts, the substitution, and then everything else was the solving. Now, step number 3 says plug your answer in to any equation and solve for the last variable. So we know what y is, we need to know what x is. So you can plug it into this equation, but that's going to be a lot of work. You could plug it into this equation, but that's going to be a little bit more work. Or you can plug it into the equation where we already solved for the variable we don't know. And that's what I'm going to choose. So for step number 3, we're going to take this equation right here, and instead of the y, we are going to plug in 1. And so when we solve this, we get x is equal to 4 minus 6, which means x is equal to negative 2. So our final solution is negative 2, 1. And we write it as an ordered pair where x goes first and y goes second. Okay? So now, as I go through the other examples, I am going to pick up the pace. So if you need to pause so you can write down things, please make sure you pause so you can write down. And I'm going to label this right here as step number 3. Okay, so here we go. Step 1, we want to solve for a variable. We find what's by itself. That is this y right here. So to solve for this y, we're going to add 3x to both sides. So that would give us y is equal to 4 plus 3x. Now that we solved for one variable, we can take that and plug it in to the first equation. So we have 6x minus 2, plugging in 4 plus 3x equal to 3. I'm going to fix my colors real quick. Okay. So now we just start solving. So here we go. 6x. We're going to take this negative 2 and distribute. So negative 2 times 4 is negative 8. Negative 2 times 3x is negative 6x equals 3. Now, when we go to do our combining like term step, that would be 6x with a negative 6x. What's going to happen is they're going to cancel each other out because 6x minus 6x is 0. And that leaves us with negative 8 is equal to 3. Well, negative 8 can't be equal to 3. So what does that mean? That means that we have no solution. Okay. So that's what it looks like when you have a no solution. You end up getting a false statement. Okay. Moving on to the back side, here we go. Let's solve for a variable. So the one that's by itself is this y right here. So to get that by itself, we're going to subtract 7x from both sides. And so that gives us y is equal to 4 minus 7x. Now we can go ahead and plug that in for this y right here. So we have 7x plus 4 times 4 minus 7x equal to 16. So we go ahead and start working on our solving process. So we're going to distribute 4 times 4 to get 16. We're going to distribute 4 times negative 7. 4 times negative 7, x is a negative 28x. And we're going to set it equal to 16. Here we combine our like terms. Our like terms are 7x and negative 28x. When we combine them, that gives us a negative 21x plus 16 equals 16. We move over the 16 by subtracting. That gives us negative 21x equal to 0, which can happen. 0 is a number. From here, we divide both sides by negative 21. And 0 divided by negative 21 is just 0. So now we found our x value. We plug it back in to find our y value. So to find our y value, we have y equals 4 minus 7, and we're going to plug in 0 for 7. So when we do that, negative 7 times 0 is 0, and 4 minus 0 is just 4. So our solution in this case is our x value first, our y value second. Okay, so we have one more example with the substitution method. So pause it, see how you do, come back, check your answers. Okay, so here we go. Start by picking what variable you're going to solve for. I'm looking for a variable that's by itself, so I'm going to pick this x. Okay, so to get that x by itself, I need to subtract 2y from both sides. When we do that, that gives me x is equal to negative 5 minus 2y. Now I'm going to take that and plug it in for x because we solved for x this time. So we have 3 times negative 5. Oops, let me fix my colors. Negative 5 minus 2y plus 6y equals negative 15. We solve by distributing 3 times negative 5 is negative 15. 3 times negative 2y is a negative 6y. We have a plus 6y equal to a negative 15. So here we go to combine our like terms. That is a negative 6y and a positive 6y. Those end up canceling out. And so we're left with a negative 15 equal to a negative 15. Okay, so this time we do get a true statement. We get negative 15 is equal to negative 15. That is true. Okay, whereas last time we got a false statement. So when our statement is true, that means we have infinite solutions. That just means we have the same line. Okay, so we did 4 examples on the substitution method. Now we're going to switch over to the elimination method. So this is just a different method that works all the time as well. It's personal preference. So with the elimination method, what we want to do first is we want to make sure that our x's are lined up, our y's are lined up, and then our numbers are lined up. And even our equal signs are lined up. Okay, and what we're going to do is we're going to try to eliminate a variable. To eliminate, we need it to be the same variable with the same coefficient, just an opposite sign. So if we're looking here, notice that we have a positive y here, a negative y here. They are the same variable, they just have opposite signs. So what happens is that if we were to add these two equations together, these are going to cancel each other out or eliminate one another. So then we just have 3x plus 1x, which is 4x, 6 plus 2, which is 8, and now we just have a one-step equation to solve. All we're going to do is divide by 4, and that gives us x is equal to a 2. Now we're going to go ahead and we plug this into one of the original two equations, so either this equation or this equation. For this one, I'm just going to use the first equation. There's no rhyme or reason. You just pick what you're most comfortable with. So I'm going to go ahead and rewrite it. Okay. And then I'm going to plug in 2. So we have 3 times 2 plus y equals 6. 3 times 2 is 6 plus y equals 6. I want to now get y by itself. So I'm going to subtract 6 from both sides, and I get y is equal to 0. And so now we can write our solution. Our solution is 2, 0. X's go first, y's go second. Okay. Now, if we look at the second example that I have, okay, notice that there's not anything that looks like it's going to cancel right off the bat. Okay, so because we solved for y in this previous, because we eliminated y in this previous problem, I want to show you that it does not matter which one that you eliminate. So this time I'm going to eliminate the x's. So if I look at my x terms, notice they are not the same number in opposite signs. They're actually different numbers. Okay, so I want them to be the same number but opposite signs. Well, if this is a -2, it's fairly easy to make this a +2. So if I want to make the second equation have a +2, I have to multiply, and if I multiply one thing, I have to multiply everything. And so I'm going to multiply by -2. Okay, so when we do that, this top equation is going to stay the exact same. The bottom equation, we're multiplying everything by -2, so we get a +2x, we get a +4y, and we get it equal to a +4 as well. So now we can go ahead and add because we have the same number but opposite signs. And when we do that, that allows these two to eliminate. -4y plus, I'm sorry, I did 4. That should have been 16. This and this should have been 16. Let me fix that. Hopefully you caught that. Okay. So now, -4y plus 16y, that is a 12y. -4 plus 16 is also a 12. So now we can divide both sides by 12, and that gives us y equal to 1. Okay. Then on this one, we need to solve for x. Personal preference, which one you want to do. You can pick the first equation, the second equation. I'm just going to stick with the first one. So I'm just going to rewrite it so I can see it. And then I'm going to go ahead and plug in 1 for y. And so that gives me a -2x minus 4 equal to -4. When I add 4 to both sides, we get a -2x equal to 0. Divide both sides by -2. X is equal to 0. So we have 0, 1 as our solution. And all we found in each one of these examples is where the lines intersected if they did. So if you have any questions on the substitution or elimination method, make sure you ask me in class so I can help you out.